All right, so you might have heard me talk about the rip sill in the previous video, but in this one, let's talk about continuity. So Zip R9, it's basically the 7/16 inch Zip R panel with an 1.5 inch poly iso underneath of it that it's laminated to. Now, when I bring that to the rough opening, you would see that Zip R9 here. And I really want to maintain continuity. And as Joe would always say, man, it'd be really nice if we didn't have to put windows and doors in a house and we could get perfect building science, right? Because we just build this wall everywhere on all 4 sides of the project, but we can't do that. Homeowners want doors, homeowners want windows, they're nitpicky like that, right? So we need to provide that continuity. So we cut what we term the rough opening inside of our primary air barrier, and then we have to connect this to the window frame. And the way we do that is by taking this air barrier and turning the corner with it. And the way we turn the corner is we oversize that rough opening 1 inch, and then we line it with 7/16 panels on each side. We'll tape that up. And now this air barrier and that air barrier are exactly the same because of the continuity around the corner. Now I can install the window and basically attach it to the air barrier, which is like attaching to the primary air barrier out here. So air barrier continuity at the windows. We got to get those jam liners and headliner in. All right, so this is an extended return detail. Now this happens actually probably more often than you would think, because a lot of our houses, we're never shortchanged windows. We put windows in a lot of places. So we have a gable that comes in, or the gable here sits on top of that gabled sloped roof. So the return comes over, and if we stopped it at our typical dimension, we would have been somewhere in the window. So what we did is we take that box soffit and extend it so that it goes beyond to the casing of the window. So basically extending that helps protect the window. It shows what I would say is intention, right? One of the problems, not intention, but intention. And if we stop that somewhere in the window, you'd look at it and go, wow, that's a big mistake. Why did the roof stop kind of over the window? So bringing it all the way across now has the language of the roof speaking to the language of the window, and we have a nice cohesive decision-making process there. So anyways, extended return on our roof system. All right, so I know I've talked about this detail, but there's always going to be somebody watching this video for the first time. So this I call my extended sill. We actually have 2 mud sills. We have this one that comes all the way out to the +1 15/16. We have one that's sitting in here. You can see it's all nailed off, 6 inches on center like it should be. And that one sits back 1 15/16 inches. Couple things are at play here. One, Zip R9 sheathing. We have poly iso underneath here, foam, easy for rodents and stuff to get in there. By extending that bottom sill, we get nice closure on the bottom of that panel and basically seals it off. We also have a nice nailer to finish any of our strapping or any of that kind of stuff too. But what this doesn't solve for is the need for the panel to be nailed off and shear. That's where the top sill comes in. So we have that additional mud sill up here. This comes down, sits on there, and I think around the corner we have a cross section, so I'll do a second detail of that. And you'll see this comes down, seats on that, and then we're able to nail it off. So the shear nailing gets taken care of, the weather resistant barrier, closure gets taken care of, and we get solid nailing at the bottom. Extended sill detail. All right, next detail, open web floor trusses. Now, you have your options, engineered floor joist, trimmable, open webs. You have regular manufactured open web floor joists. You also have solid sawn, 2x10s, 2x12s. We don't do a lot of those anymore, the 2x10s, 2x12s, just because they're larger houses, larger spans, so we're trying to get in there. So here you can see these are, I believe we have a 14-inch open web trusses. Now, what does that mean? It means that you can see we have all of these open pieces so that we can laterally put in some duct work. We can run electrical up there. We can run plumbing for a bathroom upstairs, but they really help. Now, the difference between the open webs and the trimmables that you have to be a little cautious of, these all have metal plates. And so if you're pulling wire across here, you want to make sure that you're not shearing off that casing on the wire there. When you do the trimmables, these are usually slotted and glued into that bottom cord, and it eliminates those metal plates. So you can pull wire with a little bit more confidence here. You just have to pay attention and watch what you're doing. But the other nice thing about this is, you know, when you're dealing with this, we have this overhang out on the front porch. It allows us to do some pretty easy modifications, like throw in these small little 2x8 floor joists that help us build a little study nook in one of the bedrooms upstairs. Have no fear, that is all going to get fully insulated and treated and air sealed. But you know, there's a real beauty to open web floor trusses. And if I come over here, you'll notice these are flying the full, you know, 22 feet across the house here. So there's an advantage to it also using those floor trusses, getting them to a decent depth so you can run ductwork and stuff through them. So anyways, open web floor trusses. All right, next detail, SIGA MyVest to MyRex air barrier continuity across the top plate. So notice on the outside, Zip R9, we talked about that. That Zip R9 goes up to the top plate, and that's what I'm using as my primary air barrier on the exterior of the wall. But in this case here, we have an attic that is going to have a loose blown cellulose vented attic. So we're going to bring the air barrier across the ceiling plane of the first floor on this one-story section. And the way that we provide that continuity is we use a SIGA MyVest product. I think somewhere you can see the name right there, MAJVEST. It's made by SIGA, S-I-G-A, and it comes in an 18-inch roll, although I think Brian just bought a big roll and cut his on the chop saw. But this SIGA MyVest, when you go on the outside, we'll shoot a quick detail of that. We'll show how that goes outside and basically just gets taped to the surface of our Zip R sheathing. Completing the air barrier outside, goes over the top plate, truss sits on it, and then this will simply just get brought up, and then we'll bring SIGA MyRex up to that, which is a smart vapor retarder, and we'll tape that off. And that'll provide that air barrier continuity across the ceiling plane. All right, so remember the video on the inside. If you didn't see it, I forget what set of detail videos in, but we talked about air barrier continuity and bringing the MyVest over the top plate. What I wanted to do here was show you what's happening on the outside. So notice that SIGA MyVest comes out, flaps over, and then we simply tape it to the face of our Zip R sheathing, which in this case is our primary air barrier. So we're maintaining that continuity up the wall, switching our air barrier to the MyVest, carrying the MyVest over the top plate, flipping it up, and then we'll bring our MyRex in, tape that off, and we get perfect air barrier continuity.